diagram, we can draw it again. If we take this point A outside, we can draw it like so. We have taken these points A and B outside the circuit, so we can clearly see the resistances. Now in this circuit we can see the ratio of these resistances. So let us take this as P, this is Q, this is R, and this is S. We can see that P upon Q is equal to R upon S is equal to 4.41. So this comes out to be equal to Wheatstone bridge, and in case of Wheatstone bridge we can draw it again as here we have eliminated the resistance 4 ohm which is in the center. So this is simplified circuit. In this circuit we see that 4 ohm and 4 ohm resistances are connected in series, and these 4 ohm and 4 ohm are also connected in series. So when we take their equivalent circuit, it comes out to be equal to 8 ohm above and 8 ohm below the points A and C. So between A and C, 8 and 8 ohm resistances are in parallel. So 1 upon R is the total resistance. It is equal to 1 by 8 plus 1 by 8, which is 2 by 8 or 1 by 4. So the total resistance is 4 ohm. So this is our final result. Now the next numerical. Three resistances of 20 ohm, 15 ohm, 15 ohm are connected in series to a voltage of 100 ohm or 100 volts. Find total resistance, B current, and the third thing is voltage across each. So its a solution is, firstly let us draw its a diagram. Here we have 3 resistances. These are connected to a battery. This is positive terminal and this is negative terminal. The voltage is 100 volt. R1 is 20 ohm, R2 is 15 ohm, and R3 is 15 ohm. From the positive terminal the current I is flowing and it comes again as I to the negative terminal. So in this case, firstly we have to find the total resistance. Since these resistances are connected in series, So the total resistance in series Rs is equal to R1 plus R2 plus R3, which is equal to 20 plus 15 plus 15. So this is equal to 50 ohm. This is total resistance. Now we have to find the current I. The current I is equal to voltage upon total resistance in series Rs. This is from the Ohm's law. Now the voltage is 100 volt and the total resistance is 50. So the current comes out to be equal to 2 ampere. So this is the value of current. Now we have to find the voltage across each. When we have 3 resistances in series, the voltage V divides into 3 parts: V1, V2 and V3. So V1 is equal to I into R1, this is 2 into 20, 40 volt. V2 is equal to I into the value of resistance R2, so this is 2 into 15, 30 volt, and the value of V3 is equal to I into R3, this is again 2 into 15, this is also equal to 30 volt. So this is our answer. Now the next question. A current of 20 ampere is flowing in a circuit having 2 ohm, 4 ohm, 5 ohm and 20 ohm resistances respectively in parallel. Find current in each branch. So its solution is, firstly we will draw a diagram. We have 4 resistances. These are 4 resistances connected in parallel. This is 2 ohm, 4 ohm, 5 ohm and 20 ohm. R1, R2, this is R3, this is R4. These are connected to a battery, and a current I is flowing, which is equal to 20 ampere. Now in case of parallel combination, the current I gets divided into 4 parts: I1, I2, I3, I4. So the value of I1 is equal to the voltage across each remains constant. Each resistance has same voltage V upon R1. Now firstly we will find the value of voltage V. Firstly we will find the total resistance in parallel. 1 upon R is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3 plus 1 upon R4. This is equal to 1 by 2 plus 1 by 4 plus 1 by 5 plus 1 by 20. Taking their LCM, 20, 10 plus 5 plus 4 plus 1, this is equal to 20 upon 20. So the resistance R is equal to 1 ohm. This is the total resistance in parallel combination. Now the current is 20 ampere. So the voltage V is equal to I into R. This is 20 volt. So this value of voltage can be put into this expression 20 upon 20, 20 upon 2. The value of resistance R1 is 2. So this comes out to be equal to 10 ampere. Then I2 is equal to V upon R2. This is 20 upon 4. This is 5 ampere. Then I3 is equal to V upon R3. This comes out to equal to 20 upon 5, which is 4 ampere. Then I4 is equal to V upon R4. This is 20 upon 20. This is 1 ampere. So this is the solution of this problem. Now the next problem. Find the value of R in following circuit. So here we have given a circuit. So this is our circuit. In this case, this resistance is 6 ohm. This is 10 ohm. Here we have a galvanometer which is connected to a key. So this is 12 ohm. And this is R. This resistance is 15 ohm. So we have to find its solution. So from this diagram, it is clear that this is a Wheatstone bridge. Wheatstone bridge. In case of Wheatstone bridge, we have, suppose it is the resistance, this one is P, and this total resistance is Q, and this is suppose R dash, and this is X. So for Wheatstone bridge, P upon Q is equal to R dash upon X. This is the condition for Wheatstone bridge. So putting firstly we have to find the value of Q. From this circuit, it is clear that 1 upon Q is equal to 1 upon R plus 1 upon 12, because R and 2 ohm resistance are connected in parallel. So the total resistance Q in parallel is equal to this one. So on putting the values of P, Q, P, R dash and X, P is 6 upon Q is equal to 10 upon 15. From this we get Q is equal to 15 into 6 upon 10. This is equal to 9 ohm. So here we put the value of Q as 1 upon 9. So 1 upon R plus 1 upon 12. So 1 upon R comes out to equal to 1 upon 9 minus 1 upon 12. So taking LCM, which is 36. So 4 minus 3, this is equal to 1 by 36. So R is equal to 36 ohm. So this is our value of resistance R. Now the next question. We have given diagram. So this is the diagram. In this case, this current is 4 ampere. This is 2 ampere. This is 3 ampere. This point is P. This point is Q. And this point is R. These are 3 points. So the value of the current through this branch is 8 ampere, this is 5 ampere, and this is 2 ampere. Now here we have to find the value of find x. We have to find the value of the current x. So in this case we will apply Kirchhoff law. So let us take the value of current this as I, and through this branch this one is I dash. So I is equal to, so in at point P 3 currents are reaching and 1 is leaving. So I is equal to 4 plus 2 plus 3, this is 9 ampere. Now at point Q, again this I current is divided into 3 parts, which is equal to I dash plus 8. So here we will find the value of I dash. This will come out to equal to 9 minus 8, this is 1 ampere. So the value of current I dash is 1 ampere. At the point R, there are two currents reaching I dash and 5 ampere current. These are reaching where whereas this current X is leaving the point R. So this is equal to X plus 2. So I dash is 1 plus 5 is equal to X plus 2. So we get X is equal to 6 minus 2, which is 4 ampere. So by applying the Kirchhoff's first law, which is called current law or junction rule, we can find the value of unknown current through any branch of the circuit. So the next question, a lamp draws a current of 0.3 ampere at 240 volt. Find its resistance. So solution is, we have incandescent lamp whose resistance is R and a current I, which is equal to 0.3 ampere is flowing. It is connected to a voltage which is 240 volt. Here we can apply Ohm's law, which states that the voltage V is equal to I into R. So the resistance R is equal to V upon I, which is equal to 240 divided by 0.3. This is equal to 24,100 upon 3. This is equal to 800 ohm. So the resistance of the lamp is equal to 800 ohm. Now we come to the next question. So that's all for now. Thank you.